Okay, so at this stage you should have your car, an imprint of your car inside a large box. So now I'm going to cover how to get an account. So SimScale has this great thing where it gives you free access to 10 runs of simulation. So, not log in, you'll need to sign up, and you can create accounts, and you can create an account with your Google account, or preferably with your school email. So I'd use flybar@jebelalischool.org because that's my school email. And this is useful because if you then run out of your 10 free runs, you can apply for a SimScale sponsorship, which it could be good anyway because you can put their logo on your portfolio. And you log in, apply for academic plan, and they'll direct you to a form. They usually get back to you within an hour, so if you want a sponsor on your car and you don't have any sponsors currently, it's a really good thing to apply for. So I'm going to log in. So you need to create your account. It should ask you a couple of questions, and then you should be in. Make sure you do it with your school email if you want to get an academic plan. So as you can see, I've already got a couple of simulations already. Because SimScale isn't my main one, I use ANSYS or Autodesk more frequently because they're a bit more accurate. So now what you want to do is a new project. Call it F1 entry car. And then you can put that if you want. It has to be a public product for you, unless you've applied for sponsorship, in which case if you've got the sponsorship you can do a private plan. That's interesting, I didn't realise I'd do that. So that's fine. So create project. I think I clicked on the wrong one. Oh yeah, never mind. So we're going to import your geometry. So go back to here, click on your body, make sure it's shown in the dash bar. We go export here, that bottom one, and we press step and download. That should be about it. Yep, and just wait for it to pop up in the downloads folder. It's taking some time for whatever reason. There we go. So now I can just bring it straight in here to there. Okay, now import. Oh, I'm going to try that again. That doesn't usually happen. Maybe just import it directly from here. There, 1.9 megabytes. It should work. Let's see, there we go. Okay, so you just let it process for a bit. It shouldn't take more than 10 minutes. Sometimes it might fail, and that's a problem with your geometry, which can be really annoying to fix. So you should inspect, make sure there's no tiny gaps in it. Sometimes SimScale can fix it, but most of the time it doesn't. So you need to be careful with that. Like small parts, such as this helmet, sometimes can cause issues because you can see it's got really small faces, which is just how Yasmin Schools has given it to us. Okay, so create simulation. And we want to go to an incompressible flow. So if you read about it, it says maximum Mach number is lower than 0.3, but our cars will model it at 20 meters per second, so it's far below that. And create simulation. If you want to do an advanced analysis, we can go to transient, and then I'll show you vortexes. But for simplicity of showing you, I'll just go steady state because I don't want to take up too much cloud credits. So materials, add, air, apply, and apply it to your volume. Then the boundary conditions, you want a velocity inlet. So if you look at where your car is, to press there, and we want the air coming the front of your car, because I can imagine your car is most likely going forwards. And if you look at this is your y plane, so I'm going to set that as -20 because I'm going backwards along the y. And it should indicate the direction with an arrow. So if I put 20, it goes that way, -20, it goes that way. Now we'll go to the back, new boundary condition, and it needs to be a pressure outlet and 0 pascals. So these two walls, three rather, are slip walls. These two walls are slip walls because there's no walls there in reality, it's just in a constant extending surface. So we'll call them wall slip, which means there's no drag along the wall. This one, add, this is a symmetry wall. And finally, for the floor, a bit more complicated, but for accuracy of the simulation, we're going to do a moving wall. So, where is it? Wall. And we're going to call it a moving wall. And because you want the wall to move same direction as the wind, we'll do -20 again. And there should be an arrow that indicates the direction somewhere. But you should know that if it's going behind on the y, it's -20. So that's all done. If you want to do some more advanced analysis, which I suggest looking into, you can use a section view here. There. Oh, that's hidden the car, just change the position, just so we can see the wheels. These inner faces in reality will be rotating, so you could select them and then use a rotating wall to simulate them as wheels, because they'll change the airflow. But I'm not going to go over how to do that, you should research that in your own time. So just turn off the section view. So now we're ready to generate the mesh. Oh, first we want to see the force on our car, so we need to go to result control, click add, forces and moments. The moments aren't useful, but they come with the forces. So what we're going to do is we're going to select all of the outside four faces, including the bottom and the back, and we're going to left click and say invert assignment. And that's on all of these here. So just once again, in case you didn't catch that, select all these faces. That one, that one, that one. Left click, invert assignment. Okay, that's quite important because you won't be able to see the results if you've not selected this correctly, which will be annoying because you have to do the thing again. So the center of rotation you can ignore, and just ensure it's in newtons. So yeah, and then we can press add again, this time coefficients, which will give us our drag coefficient. So again, we can ignore that, and for our drag direction, if you remember from earlier, we've got -20 meters per second and 0. And then our free stream velocity is 20 meters per second. The length of our car should be, you can measure this, but actually for entry, should be around 170 millimeters. And the reference area, if we just go back here, Give it a sec. Reference area is basically the area exposed to the wind. So the way I can calculate that is doing a sketch, just selecting the back plane, or any plane that's perpendicular, and just basically go over every single side with the project convert tool, or you can press U. It can take a bit of time, but I'll do it. So you only need to do that out to edges really. And you can even do half the car, which is what I'm going to do. I'm actually going to include this as the reference area because we'll have the tether guides, so it's a bit more accurate. Split it right down the middle, and hide all these parts. Then don't press tick just yet. Make sure all of these entities are closed. Now I can press tick. Just select all the stuff that will be in the wind. Oh, I'll just do that again. And then press the measure tool, and I've got 186.245 millimeters squared, so I'm going to bring that in here. I believe I can do 2 times because we only did half the car, obviously. Oh, it doesn't do millimeters squared, so just use so it'll be that, and then we can do 2 just copy that value and put it straight here. There. So for the sign faces, we're going to do the same thing. Select every single outside edge, invert assignments, tick, that should be done. So that's done for this video, and in the next video I'm going to cover how to start your simulation, which involves the mesh and the simulation, and then some common problems you might face with your mesh and how to fix them.